Next.
This is the second question, and it's asking the final velocity. First, we need to understand the two positions, their energies are same. And
Again, sorry.
In the first position and the second position, the total energy doesn't change. So the first position is because it has height and so it has gravitational potential energy, but it still has initial velocity. So it also has kinetic energy. In the second position, the ball is almost touching to the ground. So
Almost, yes.
So it doesn't have height, and the velocity is the largest at this moment. So in this position, it only has kinetic energy. So the formula, so in the first one, the EP plus EK equals to the second one's EK, and we also know the data, so we can substitute all the data into this formula.
Okay, data or values. Okay, substitute in that formula. Okay, good.
And after that, we got the final velocity.
Which is approximately 31.6.
So for the question 2, like first look at the diagram. We can see
Is that question 2 or question 4?
Okay, question 4.
Okay, question 4.
Look at the question 4. Like first we can look at the diagram. The ball have this in the E1 like position energy in the position 1 and energy in the position 2, and also we
Downhill, right?
Yeah, energy in the position 3. And so in this 3 position, the question want to ask about the velocity which in the position 2. And so if we want to know the velocity in the position 2, what do we want? Like because according to the law of conservation, in this kind of diagram, in the 3 positions, the energy of the ball, the mechanical energy of the ball, total mechanical energy
Of the ball.
in the different position, E1,
Correct.
E2, and E3 is equal.
Yes,
it's
correct.
equal, but we only can use E1 to get the E2. Why? It's because we don't know the E3. If
Right.
E3 only have the connecting energy for the total mechanical energy, but if we want to know the kinetic energy, we have to know the final velocity, but we don't know the final velocity. So we can use the mechanical energy which in the position 1. The energy which in the position 1, we only have the potential energy, because the kinetic energy
Is equal to 0.
the inertial velocity is equal to 0, so we don't have the kinetic energy.
Correct.
So the potential energy equation is the mgh1,
Right.
and we plug in all the data in here. We get the 35,000 joule for the potential energy which in the position 1.
Okay,
And
good.
we can we need to, because the E1 equal to E2, and now we know how to get the E2 is the we have in the position 2, we also have the kinetic energy and potential energy, both have. So we use the mgh2. Now we need to use H2 is because already in the position 2 we
Correct.
have energy
Very
attached.
good.
So we plug in all the data, and we plug in all the data which in the kinetic energy, and we got this equation. Now, because according of the E1 equal to E2, we can get the 35,000 joule equal to the equation which in the position 2. And step by step, we can get final on the velocity which in the position 2 is equal to the square root of the 800 meter per second, and we put in the 0 meters this kind of numbers. We can get the 28.28 meter per second is for the velocity which in the position 2. Finish.
So from U equals 0 to position 2, velocity 28.8 meter per second. Okay, next. How about position 3?
Position 3. So if we want to get the kinetic energy which in the position 3, we need to put the velocity which we got in here and put on the 1/2 and plus the m and times m and times the velocity square, and we can get the energy.
Kinetic
energy.
That's E3 equals
E3.
kinetic energy
Yeah,
because
the
the
total
EP
mechanical
is
energy.
already 0.
Yes. Finished.
Okay, good. Very good. Next. Last? This is it.
Yes.
Okay.